if all life has this information imperative and evolution has selected for these sensory systems, these mechanisms for gathering information from the distal environment and integrating it into an adaptive response to that environment, then it must be these things, you might think, that really differentiate human beings, that have taken human beings from being on the very edge of extinction to over 7.5 billion people on the planet today. But in fact, when we look at any individual sensory system, human beings, they're just not very impressive. Just as we're not particularly strong compared to many animals, we're not particularly fast compared to many animals. We don't have sharp claws or teeth or other defensive or offensive weapons as part of our physical being. Right? Our sensory systems really aren't particularly impressive when compared to sensory systems in other animals out there in the animal kingdom. So to illustrate this, I'm going to go through a sort of visual system throwdown, compare the visual system between, on the one hand, human beings, and on the other hand, the mantis shrimp. And the mantis shrimp is actually an inappropriately named stromatopod. It's more like a lobster than a shrimp, really. But nevertheless, our typical human representative here, I believe that's Molly Cyrus. And when we look at the human visual system, we see that human beings have 4 photoreceptors. So 4 cells in the back of our eyes that are sensitive to light. That might seem kind of impressive until we look over here at the seemingly humble mantis shrimp. It turns out they have 16 different photoreceptors in their eyes. Now, we might say, yes, but we have 3 that are devoted to color vision. So we have all this color vision apparatus in our visual system. Surely that differentiates us. But again, the mantis shrimp, the lowly mantis shrimp, has us totally beat here. They have 12 photoreceptors for color vision. In addition to that, they have 4 photoreceptors just for polarized light, coherent light. And their sensitivity in their photoreceptors ranges all the way from the ultraviolet in the electromagnetic spectrum to the infrared in the electromagnetic spectrum. So they have a much wider range of sensitivity to electromagnetic radiation than human beings do. Our sensitivity really runs only from about 380 to 700 nanometers. So visible light is actually a very small part of the electromagnetic spectrum. So you might think, well, we'd have binocular vision, though. We have depth perception. And surely we've got the mantis shrimp beat there. Interestingly enough, though, the mantis shrimp really has a sort of impressive system here. They've got 3 different opposing planes in the back of their eye where their photoreceptors are housed. So each of their eyes provides them with this 3 different angles of comparison on the visual field. So it looks like each eye of a mantis shrimp allows it to see in depth, whereas human beings need both of their eyes, that binocular comparison, in order to see in depth. So it's not the human ability to gather information from their environment through things like their sensory systems that has differentiated them from other animals and been responsible for the really remarkable flourishing that we've seen, particularly in the last, say, 50,000 to 100,000 years. So what is it then that distinguishes human beings from other animals, from other forms of life, that's allowed them to become so successful that they're really essentially transforming the entire planet, both its surface and its atmosphere? Well, human beings are remarkably good at creating and utilizing complex and diverse information ecosystems. So in the next lecture module, I'll give you a couple of basic definitions of information ecosystems and talk about what it is about human beings that I think really differentiates them from really all other forms of life in this regard.